Good evening, all. Welcome, Aki. Nice to see you here. Welcome, Steffi, and welcome Bad at Categories, also known as Sleepy. Aki does like her naps, though, you know, things happen. I mean, I wasn't gonna say that, but yes, sure. You did kind of mess up your sleep schedule, this is true. Naps are good. To be fair, naps are good. Welcome, Amy. So, yes indeed. Today, we are assembling this board, which is SPIFlashProgrammer Revision 2. This is the interactive BOM viewer, bill of materials viewer. And I've actually done a couple of things that you may not have seen before, and I fancy showing behind the scenes before we get going. The text up here is normally a little bit smaller. I've bumped the font size up about 50%, so it's 15 point instead of 10 point, which they've already got the font sizes bumped anyway, so that's actually quite big. So hopefully when we put this in the corner, you'll all be able to read it and it'll be good. The second thing is that rather than exporting the, well, technically I have exported the full thing. Technically I can do that and we can see all the pads, but that's a lot of information, so I've actually opted to show just the fab layer and silkscreen. So, welcome Eston. And I now have a new static map, anti-static map. So we are somewhat more static safe than we were. This is very nice. Now, we have lots of parts. This is going to be quite the build. And you're probably wondering why I've got two different colours of boards here. I mean, technically it's a part cookie, I guess. Oh, I see. I'm just trying to figure out where I put the parts, because I just realised I'm knocking my microphone around. Also, hopefully today sound should be in much better quality, because I've actually done a whole pile of work on cleaning up the audio coming into OBS. So, we'll see what happens there. I think I'm going to put the parts on the floor for the moment. They're in bags, so it's okay. So... oh. Just knocking the light, as you do. So the reason I've got two different versions of the board here is that I did a spin. I'm not going to say how much this cost me, just that people who know I was swearing quite a lot about this. And, well, there's an electrical short on an inner layer. Oops. And you'll notice that there are some parts decidedly missing on one version of this that are not missing on the other. So already I've had to do a respin. So oops. This is the one we're actually going to be assembling today, not the blue one. Blue is normally my prototyping color, but in this case, we'll just ignore that blue one exists. Yeah. Yeah, respins happen. I just wish it didn't suck in terms of imports and time taken, and I have a big pile of these. So I hear you wanted some Flash programmers. There's 6 of the first spin and 5 of the second. Start your own board house. I mean, I guess. So, and this is going to prove an interesting challenge because there's my soldering iron versus the board. This thing is quite small. Welcome, Nas. Also, I spotted that Atti's crept in. Welcome, Atti. The other board that I've got here is a Black Magic probe. This is the board that we designed to fit right here for programming. So this is going to be an interesting mash of boards. Yep. Well, yeah, but still, that thing's just, you know, tiny. Thumb for size. Oh, actually, I can do one better. Have a YubiKey for size. Yeah, FL4 and copper-filled sandwich. I don't have a FOMU. I didn't even know what one of those was until I hung out in Discord with you lot. Yeah. I can imagine. Given what I can see here. So... maybe? Oh yeah, I guess, if Eston's okay with this, I should fill you in on what's gonna happen, probably by next Saturday. I don't know how okay Eston is with me telling you all. Okay, so, as you are well aware, if you have watched Eston's stream, Glasgow Rev C2 has just been first lit. The first 8 have been made. Normally these stay with the dev team, but Eston, being amazing, has gone and opted to send me one of them. I'm still pinching myself, going, wait, what? So, among other things, this actually helps with the keyboard project, because this actually helps... Well, there is that. Thank you. But it helps with the PS2 stuff, because now we have a board which we can plug the keyboard into without crashing my desktop, that will act as a PS2 host and help us do validation and verification and figure out the firmware, which is cool. Now, put the iron on, which is the open strain. This is the open strain. So we're going to start with a USB port, which I can just click. Hopefully this is nice and visible for you. I am so excited about getting that board, and just a little overwhelmed if anything, but not in a bad way. As Eston probably knows, I am actually signed up onto the crowd supply campaign, so I get notified when that goes live. Which I'll throw a link in. because I happen to have it rather handy. It's some really nice hardware, so do sign up and get one. There's also some really good software. White Quark and team have done amazingly well there. Yes, you do. It's all good, dear. It's all good. Actually, let's make this so you can actually see what the hell I'm doing. I mean, still good hardware. I mean, it would be kind of impressive if it was already C2, seeing as those are not yet for mass production or supply, and, you know. There we go. Oh, it even helps with focusing. That's nice. Static matter's having quite a few benefits here. So much flux. You've been working on fixing things, so it's all good. I think you'll get quite a few more than that, Aki, to be fair. I need to skip a song. It's a good song, but, like, I really don't want that whole mess. Hey, nice. Oh, Aki, you tease. Let's put that there for a moment. I'll quickly visually inspect that because, awesome. I'm glad your new connection's working out well for you. That's looking good. How's everyone doing, by the way? Oh, I'm glad to hear that, Eston. I know you were having a bit of a bad time the last couple of days. Ooh. Yeah, I'm sorry to hear you had a really suck day on Thursday. It'd be really swell if I could stop shaking. Now, I need... So we can now mark that connector as done. I want a 1 meg resistor. This is 1 millimeter. That's the flash. Into that one. LEDs. Ah, there they are. There's the 1 megohms. I knew there was one thing I'd forgotten to go and grab. I'll be right back. I need to go and grab my scissors so I can open the bag. This is with 1 megohm resistors. There you go. Yes, it is. I'm back with scissors. Yep. I wonder how the berating of a certain Liz Truss is going on here in the UK. There's well, let's just say that some of her own colleagues took umbrage in what she did with regards to the whole... Yes, she needs hugs. Aggie needs hugs. Ah, they're still collecting evidence. Of course they are. Oh, come here. On the keyboard project side of things, I got a really fun delivery today of 330 RGB LEDs. Which, yeah, LCSC is awesome. I know, right? The little tiny thing right there, it's just cute. Ah. Straighten up on the pads, damn it. Yes. Everyone needs good hugs. Even those who are like, I'm not a hugging person, actually need hugs. Yes. Ah, that's fair. Ooh, that's getting quite hot. Which isn't too surprising. Now, I already happen to know that the capacitor the capacitor I need at this stage is a 0.1 microfarad, which comes off of this giant reel of parts. That works, Staffy. That works. Oh, that's a massive mood. Digital's just not the same. Yeah. I struggle with the whole social contract of hugs and that kind of thing because I'm naturally quite a huggy person, like autism. Right, I'm good with this so far. What I'm going to do next is I'm going to actually put the 3.3 volt reg on. Yeah. Yeah, that's fair, Steffi. So I'm going to put this diode on, which is actually an LED. So if we quickly looking, if we quickly go looking, because I can't speak apparently, at D3 here, we can see that it's an LED. It's actually a green LED. So I'm going to put that on, the 3.3 volt reg on, and then we're going to power the board once I got enough of those parts on, just to make sure that it's a happy board. Oh, thank you. Looks good, doesn't it? You're very welcome. Somewhere in this bag. Ah, there they are. Our LEDs. This is from Multicomp of all things. Oh, okay. I tell you what, with regards to that, after stream, I will send you a link for what exactly I got there, here. Because it's not too big a map, which I quite like. Or at least, I don't think it is. Yeah, this actually is good for high temp soldering. I don't know that you could cut on this, but certainly high temperature soldering, not a problem. As already shown, like, the joints there did flow into the back, and I've not damaged the mat even slightly. Like, this is where I've been working, and it's a nice rubbery SD mat. Because the other ones kind of don't like heat. The vinyl ones burn. I would not suggest that kind of temperature to your face. That would hurt. That would hurt a lot. For all of like the 1 microsecond you could feel it. Nice. Yeah, I actually do want a silicone mat as well, but I don't know that they make them in static dissipative or anti-static forms. Come on, LED. There we go. I needed to see the arrow on the part before I can actually put it on the board. Okay, I knew what I was doing before was bad with regards to using my desk bare. ESD protection is actually quite important, to be fair, especially when you're building boards like this.
Money never sleeps, pal.
I'm gonna skip this one. So, according to the silk screen, pin 1's down this... Oh, you can't see that. Pin 1's down this end over here, so... If I'm not mistaken, this... LED goes this way around. I'm inclined to go and grab the datasheet and check, but, like, Let me actually quickly check. I should check. That's the keyboard. As for a digital multimeter, I'm not sure that mine would light this LED up, so, like... It's easier just to go and look at the data sheet for it. Which, I'm gonna shatter an illusion real quick. This is actually a web browser. So I'm just gonna open the data sheet up here, because I can. Oh, I know. I appreciate that. Okay, the arrow here is pointing from the pin 1 end. So I was actually going to install it backwards. I'm glad I checked. Come on. There we go. That took way too much solder. Go. Awesome. I'm now really intrigued by that because I would love a mat like that. This one's technically a little bit big for my desk, but it's as good as I could get. Right, how do I want to do... I'm just trying to work out how I want to do that. First, the logic level translators. I'll come back to those. I think... Okay, we're gonna need those ones. That's good. Dual MOSFETs, those go on the back. There we go. VREG. I also need 0.47 microfarad. Oh, I've got to go digging for that. Nice. Really don't get that kind of service often anymore. Right. I've got enough regulators here for 2 keyboards and 2 of these. I've kind of gone for, let's have 2 of these built by the end of stream if we can. Excellent. Fits its pads very nicely. I am so far quite enjoying playing with the round rect pads. This is the first time I've done that. As actually you probably already all knew. Indeed. That's horrible. I'll fix that in a moment. It really does. Huh. Thank you, Atty. I'll have a look in a bit. It's definitely created some shorts. Whoopsie. Oh. Grab the other new toy I've got. Let's go for the I'm Feeling Lucky solder wick, which is the really small stuff. It's really hard to tell if I've still got a bridge there. Okay. Yeah, no, that definitely cleared the bridge. Awesome. I'm trying to backfill some of that pad because it was quite dry. I've gone and created a new short. Yay! Flux time! Okay, that looks better. Yeah, just shiny joints. No more bridging. That's good. Not very happy about the joints on this side though. So I'm gonna just quickly do a little dab with the flux and redo them. Just like that. Now, backside. I think I expect the resistors on this to be 470 kilo ohm? No, ohm. but I'm inclined to actually put 1Ks on, because I've got plenty of them. We'll see. We'll see. I've lost my scissors. Oh, there they are. Also, for those who were interested in how Toru came out, she's looking rather splendid. Even if they did munch the artwork very slightly. Should explain, these are the 1 microfarad decoupling caps I'm putting on the back. These are 0603. Or, in other words, the smallest I go to because, like, I shake enough as it is. I don't need to make my life worse. I hate having to reheat it quite that many. Ooh. Ooh. Very nice. Oh, okay. Well, we'll see how far we get done in an hour then, huh? Now, there are 4 of those caps on this board, so I can't quite yet mark those as done. Although, what I'm actually going to do... We've placed that one. We've placed that one, and we've placed that one. Oh, she's got carpet. At least in that part of her flat. So these are the 0.1 mics. I mostly don't care about losing passives as long as they're common passives that I've got lots of. Which, let's be honest, I use a lot of the common size stuff, like, how many point ones is that? That's 15.1 microfarad caps on this board. That's fair, Esden, that's fair. Well, Asden, you might be in luck on that one because of my impulses to need a proper inventory management system myself with the sheer number of parts I have sat in my flat right now. So, I guess that's payment for a Glasgow? Yes. Okay. Yes, that's fair. I like her properly written set of, this is what I need it to do. So I can completely get behind that. I'm just trying to take this nice and slowly because I know I'm shaky today. And I've got a lot of parts to pack on this thing. Okay, Auntie, take care. I keep managing to cause shorts. Luckily my tweezers actually fit in here. Woo! I'm glad more things are starting to work properly with version control. Yeah, that's fair, Steffi. Ah. Just accidentally smack a whole pile of different buttons. Yep, show me. Yeah, that's fair. So I need to go and find that 470 picofarad cap at some point. But for right now, I need to find my, well, it's technically 440 resistors, but I actually got the next closest value I could, because fair. Ah, I should put the regulators away. I just had them floating on my desk still. Not great. There's a standard behind those. I can't remember exactly what the standard is, but there is a standard. So yes, if you've got banana plugs that work with one DMM, they should work with another if it's following the standard. Which, let's be honest, most follow the standard. You mean when it's not frustrating you? Yeah, most are shielded banana plugs. Oh, come on. Yep. I'm glad we've moved past those really quite dark times. Ooh. Yeah, I saw you got the boards for that in today. Congrats. There we go. I find that doesn't work out very well for me, Steffi. Don't forget I shake like hell. And also the muscle tone thing. It's one way to make them go pwing across the room, and I never get to see them again. That's fair. I do not for this project because Rachel's not always the smartest in the room. Not by a long shot. Welcome back. That just wasted a whole lot of solder. I'm just going to turn the board around. It's easier than trying to work around a whole pile of parts. I have it, yes. And yes, it's a Met Cal iron, it's a PS 900. This is my very trusty PS 900. I've had for quite a few years now. It's looking good. Come on, there we go. Fair enough. I need to quickly go and find my 470 picofarad caps, so I'll take a moment and quickly look in my keyboard stuff. Got him. The nice thing about using the same regulator on this as I used in the keyboard is the parts list for this bit of the board is the same handily. Oh, really? You're gonna do that on me? Thank you, Flux. Some very sticky Flux. I need to clean the board down before we power this. I'm not happy with how that capacitor is positioned. That's better. That's taken a surprisingly long time to build the power section. Right, I will quickly go grab my isopropanol and we'll clean this. Check it for continuity issues and then power it if it's all clean. That's certainly looking much cleaner. I do need to fix a small little oopsie on the backside here. I'll get the ISO off the desk first, because we don't want to cause an incident. I'll also get the DMM on.
I can imagine. And tonight, I am going to do the impossible. Groovy.
Interestingly, I'm not actually using a spray bottle. I probably should be, but I'm not. Oh yeah, that's fair. Right, let us check that we don't have any shorts that we're not expecting. Should be fine, but fair. I bought my big bottle of IPA quite a few years ago. Yeah. So that's our grand continuity. We don't have any continuity to the yeah. Fair enough. I am closer to a decade with mine, and I've got like 25% left. So I've got no continuity to the shield, which is what we want. That's why we've got these parts here. We shouldn't have any continuity to... I actually need the schematic up. Not the schematic, the board design. Switch to the PCB layout. Thank you. Yeah, okay. So that middle pin should indeed be ground. It is. That's the V-bus connection. And that's another V-bus connection. We get nothing there. That's great. And then no continuity on this side either, which is exactly what we want. So this looks like it's good for power up. The only other thing I will quickly check is that this pin and ground are not connected, which they're not. That's good. That's the SPI power. Oof. That's... I mean, calibrating it is easy enough. But, like, that's a lot of money. What did you... Oh, ooh. Jelly jelly. Ah. Sorry, trying to get my multimeter stuff all out of the way so I can get it off my desk and we can try powering this up. Fair. Now the question is do I use my power supply, or do we just plug this straight into my PC and hope? Shall we try and not kill a USB port in the process of doing this? You would say power supply unit. I mean, it's getting it out though. Like, we know that the power circuitry on this should be just fine. Because it's the keyboard's power circuitry minus the switchy part. Sure, fine. And here we go. Nothing doing. Interesting. Yeah, nothing doing. That's interesting. I was expecting the LED to light. I know I've got 5 volts coming out of a port on my keyboard. Valid questions. Valid questions. I'm gonna quickly check D-message just to check if I've got any overcurrent events before I go messing around on the board. I've got no OC events, so I'm inclined to plug her in again. So I checked with it unplugged. Grab my DMM. Yeah, because that's not even getting warm. I can't feel any heat off this board at all. And we'll validate some voltages. Oh. Well, this is already going well. That's 5 volts. I'm sorry, what? That's the regulator output. That should be 3.3 volts. That's not 3.3 volts. Just a second while I get the regulators back out the pile. TLC 1015 3.3 volt CT 713, not 1. Barnard's got me the right part according to the baggie. Sure. Is not very readable. Oh, the markings won't help you with this. This chip is marked up as... Oh, I guess me unconnecting it. B5QC. So... .3 volts. Give me a second, I will bring up stuff in a browser in just a moment. Actually, let me transition you over to that real quick and make it so I can get at my keyboard properly. Would actually help if I went into the schematic. There we go. So yeah, that's the part number that Farnell has supposedly sent me. And we've given it power and it's not in shutdown. We've given it ground and we should be getting 3.3 volts out. Which is not what's happening. And we've got ground on pin 2, power and shutdown are 3.3 volts. It is inverted, but indeed. Yeah, I'm trying to find that table. So the part number is B5 there, so that's a good first sign. And the other two bits are Q and C. Yeah, that definitely wasn't 3.3 volts we were getting out, that was definitely 5 volts. Which is not good. I now have more questions than I have answers. Also, the schematic here shows the bypass pin as pin 4, pin 5 is our output, 1 and 3 should be 5 volts, and ground on pin 2, which, get rid of that one. It's exactly what we have going on here. Oh! Welcome, Sylvia. Yeah, that's exactly what we've got going on. If I switch back to camera real quick, and I pull my multimeter in the shot, along with probes, and we rehook the board up, there we go. We can check that, but I didn't see a short before. I mean, in theory, 5 volts only exists. You can't see that, worth a damn. 5 volts really should only exist in this small section over here. So it should be really very hard for it to go out over there without us knowing. Because there's no wiring. Yeah, that would be a big fat, there's no short. Let me plug it back in again. This is obviously not drawing any particular amount of current, which is quite nice. And if we check Sorry, I'm having probe problems. If we check ground to the output here, oh, now that's interesting. We're now not seeing an output. The ground I'm using over here is a thermal pad ground, which is ground throughout the whole board. And if I unplug it real quick. Yep, we've mounted the caps already. If I poke in, put it in beeper mode again. There we go. So if I get the right pin on there, then it's just a general ground throughout the whole board. Okay, so we got our 5 volts again. I'm not changing where I'm probing. Oops. Yep, that's definitely 5 volts. That's not 3.3 at all. Okay, I'm gonna check and see if we've got the LED the right way around, because if the LED is the wrong way round, it is possible that we're backfeeding. But it should be wired from 3.3 volts to ground. Interesting. Yeah, but I'm wondering if I've got a short somewhere in the board to my 5 volt rail. No. That LED is actually probably just fine because it's reading as a diode still. I mean, I can connect it in one direction and we get going back in diode check mode. We gotta, it's a diode. Yeah, that was definitely, sorry, I can't prop this up very easily, but
driving humans to the brink of extinction. Earth's salvation is left to a man made half flesh and half robotics. We call him the superhuman.
The other way around, this LED is still reading as a diode. I actually don't know which way around that LED should really be. It's not easy to know. Okay. That probably means it went insta-pop at that point. Even though it's got a current limiting resistor. Go figure. Sorry, trying to get my multimeter probes back out of the way. I'm just going to pull off just the diode, we'll check it, we'll check a new one, and we'll put the new one on the right way round. Then we'll worry about that regulator. Or I can already kind of do this, Steffi, by, without having to take lots of parts off, I can put a USB port on the other board, which there's a second one that we're going to be building, and we can see what the hell happens. Do we get 5 volts where we're not expecting it? It only needs the USB port. That's a new LED. But I am not used to working on this scale of hardware at all. I mean, it's not a minimal change to get that regulator off, that's why I'm not going to just do that. Taking the LED off is far easier. That was the cap of that LED that just cleanly came off. How would tape help me here? I don't quite follow. Well, that LED is definitely dead. Ah, I see. Because of surface tension, that actually won't come off if you just wick it off. Like, the wick won't actually get you the full way off with the part. Oh, that's a nice clean pads. Oh no, it's way worse. With an iron rather than a hot air gun, it's way worse after. Because now you got a little tiny amount of solder you're trying to heat that is holding the entire part down. On every single pad. Irons don't do that well. In my experience, at least. I'm just trying to wonder what I do now. I'm gonna go and get another USB port out, and I'm gonna go and put that on the other board. Haha. Indeed. Yep. Ah, go in the holes. There we go. Indeed. I mean, it is an excellent hobby, so, like, can't fault him. Come on, stay. Stay. Okay. Check those joints. Nice. That came out nice. And, well... I'll try and not forget I've got an LED on top of my solder now. Ah! Come back here. Chasing banana plugs. So, we should have, that's good ground. And I get no other connections there, that's great. There should be 5 volts, no connection to the output. so that port is the only thing on this board. There are no shorts in the power entry section. PCB is now live, and we're back into Volts mode. Yeah, that's exactly what I'm planning. Interesting. Very interesting. The fuck? But there's no connection between those two. No, I haven't yet mounted that resistor. That's just that port. Just that one port is on this board. I haven't done anything else to this board yet. There are no other parts. As you can see, that's the resistor there that isn't populated. PCB layout for this section is as follows. So this is the pad that Sylvia just got me to test. It goes through this wire, back under into the resistor. There are no other connections to this wire. No shorts to ground there. And then the backside, the other end of that resistor is ground. We can get the Gerbers back out from the order easily enough. Because JLC is great. It is JLC. Yeah, I'm just about to do that. We're about to go and pull the Gerbers back out from the order. I just need to move some stuff so that I actually can use my keyboard. I just sent an LED flying, didn't I? Bollocks. JLC PCB. I'm just trying to work out where the LED that I just accidentally went and set flying actually went. Because I kind of need it. Yeah, that's not a very high quality USB cable, so I'm okay with it being a... It was actually nearer to 4.9 rather than 4.8 volts. So, like, that's not terrible. Oh yeah, good luck finding it indeed. Sorry, just signing into JLC at the moment. Which I'm doing off screen because I don't want you to see where I live. For obvious reasons. Just, you know, accidentally doxing myself would be... Oh, Aki indeed does. As does Aston. And I'm okay with this. Electronics, SPIFlashProgrammer, board, Gerber, save. Ah! Yeah, you know the very approximate area, and I trust you to not dox me. So... that was my original Gerber upload. Those are the original Gerbers. That means these are the production Gerbers. Yeah. Now, we are interested in the top copper, the layer 2 copper, layer 3 copper, and bottom copper. Yeah, I just didn't want to open everything, especially as that file actually contains all these other files. Yeah. So this is what got made. And that all looks fine. There's no shorting to this pad at all. This is a nice isolated pair of pads. We can do that. Just waiting for my camera to start back up. There we go. I'll put that one out of the way for a moment. See if... No, my LED's not in my solder anymore. Oh, I found the LED! Yay, we found the LED! I'll leave it on the static mat this time round, so it's not gonna go flying. Because I can actually see it okay on the mat. So if we just check for my own sanity, continuity mode. I'm pressing quite hard. No beeps. If you put me in ohm meter mode. Oh, interesting. Why is there... Yeah, I am seeing, my bipop probes there and there. It's fluctuating a bit, but like that's between the left end, the what's it's supposed to be floating end of the diode and the power pad of yeah. Now if I change that out for the other board, no, Steffi, I was saying that, no, that's more than my current limiting resistor. I was saying that I was thinking about using Osh Park, but I wanted the particular finish, so... My current limiting resistor is 470 ohm for a LED current of 1 milliamp, if I've got my maths right. It's okay, Steffi. It happens. Just quickly measuring the impedance on the regulator power pin to the regulator output pin. It's in the kilo ohm range still. Spooky PCB indeed. Welcome back. Welcome back, Amy. We're having issues with SPIFlashProgrammer boards where... Well, if I put power on this board, we're gonna see some very weird things happen. Not like blowing up in my face things, but just weird things. So this has just got the regulator, USB port, and some passives up here. I should actually check my ESD mat. Let me just see what my ESD mat resistance is. Few kilo ohm. Like, but it was still doing the weird things when I was holding the board up in the air. Oh, I would expect this low. This is carbon based, so... But I am piercing into it slightly. Like, I did just go and put a slight dent in it. I can indeed put the board on. I'll have some diodes for it to insulate against. That's paper it's on now, which is definitely not conductive. And we'll do the same thing for the other one. I mean, I don't think this is going to change anything. Interesting. Do we get the same behavior on this one? No. I mean, it's in the megohm range, so it shouldn't really matter, but, like, that is not infinite. There is a connection somewhere in there, though it could be the flux. Let's just double check this. Okay. I mean, that doesn't really change that we were still seeing some really weird shit happening there. Yes, I'm on the correct LED pad. I was probing this pad right here, which is the one closest to the word CERN, which is... Sorry, Steffi. I don't think this is JLC's fault as such. What we're going to now do is I'm just going to quickly put power on this board, and we're going to measure that same area of the board. Oh, fair enough. No, I was definitely probing the right pads on the board. I'm glad you checked. Honestly, I'm glad you checked. So we're in voltmeter mode right now. If I go back on to the output... Hey, what do you know? 3.3 volts. Now on the resistor. Okay, that was fine. 4.92. Not really shorting, just getting pulled around a little bit. That's fine though, we can run it on, like, this bag, that's not a problem. What I do want to know is why the LED wouldn't light, because even with it doing what it was doing on the ESD mat, the LED should have lit. So that's still a problem. Now I said I would try testing an LED for polarity. Sorry, I'm trying to get some stuff off my desk before it falls on the floor. Where's the bag gone that I... Oh well, whatever. So, one LED, in all of its tininess, in one direction is showing, oh, this is such a pain. It'd be really great if I could get a... Oh. God damn it. Nothing in that direction. And nothing in what? Oh. That's because I'm in ohms mode. Okay, nothing in that direction. Also nothing in... What the... Okay, I know what this is. It's because this multimeter doesn't do LEDs well. So it's probably fine. Good girl. Yeah, my V drop's too high for the multimeter. Yeah, that meter's more designed for like current measurements and general DMM use, not this. Which is why it sucks at trying to measure LEDs like that. I wish I had a multimeter that could do that, but I don't, and they're kind of out my price range for just going, yeah, I'll just buy a multimeter today. So, we're all happy that this triangle here definitely points towards pin 2, yes? And we're all happy that pin 1 is definitely the end that should be getting power, yes? Cathode. It says 2 on the diagram, that's why I'm saying pin 2. Yeah, I unfortunately can't really fix that. Oh, there you go. Now you can definitely see them. So this arrow points to pin 2. Which is the cathode, I think? Pin 1 should be where I put power. And there we go. That would be 3.3 volts here, yes? Ignoring the fact that the silk screen is backwards because apparently this is reversed to... Oh, I agree with you that it's a horrible way to talk about your orientation. Yeah, on this screen, arrow points left. Yes, that's right. The LED's on the top so that you can see this illuminate when you put power on the board. Yeah, pin 1 connects to 3v3. Perfect. Okay, we all agree then. Through the regulator. It is a poor yes. I have the pour turned off, to be fair. Ah. Okay. That is definitely the right way round this time. Fair. I notice, did you update your theme so that the bottom side's blue and you've got a grey background? Welcome back. Ah, that works. Working better for you? You're very welcome. That's fair, Aki. That's fair. There's nothing wrong with your choice of color scheme. Copy link location. Oh yeah, it's nice. I hope that that's making it much easier to distinguish the layers in particular. Because I know you were really having a struggle with that on your boards before. Good. It's doing its job then. So we've got that placed. We've got that placed. So I better update things there as we go. So, bringing back in that, let's plug it in and let's see the LED light this time, right? Hey! Mazel tov! And that's not too bright either. Okay, we can finally get on with the rest of the board. Oh. The next part I'm going to put on, because I'm not sure that we've necessarily got the footprints right, etc. I think a mix between the diode being backwards, which is explaining why the other one got fried, because my footprint's wrong. The silkscreen says to put the diode facing towards the certain text, not away from it. Or rather, sorry, pin 1 is supposedly this end, which is wrong. Pin 1's this end. So we've got to fix that for Rev 2. Sorry, Rev 3. And there are a couple of things I need to fix with this hardware anyway, like the licensing here says it's 1.2 and it's not, it's actually Sun Open Hardware License version 2 strict. That's a vestigial thing from when I actually did use the 1.2 license on this board. What else? So yeah, we now know that the diodes are all we now know that the 2-pin diodes are all backwards. Makes me actually want to put the other diode on so that we do that while we know which way round those definitely go. And I'm also going to update the other one to the same point of progress so that we've got 2. I'm trying to find the LEDs again. Too many parts. Oh, we'll need those next. Oh, that's the wrong LEDs. Ah! Oh. Found them again. Ah, come on. Okay. So we've just said, I really should keep the tab open. Our pin 1 is the opposite to the board's pin 1, is the side with the arrow start. So it's that way round. Okay. So this LED I'm putting on is the power indication LED for the target. Ah. Come on. There we go. Just trying to get some solder to flow. It wasn't liking. And this is actually driven through a FET on the back here, so that when you put power in, it turns the FET on, it turns this LED on, but otherwise this is off. But it's powered through the 3.3 volt side of things, so that I had enough V-drop, because so we can now mark the LEDs as done, on one at least. Let's do the same thing to this one. Let's get these both to the same point. That was close. That one's the right way round here. These are frustrating LEDs to work with. And that's the right way round for there. I like that they're really small. I don't like that they're really fiddly. Yes, that's a good idea. Mm-hmm. Ah, well. Sleep well, Freya. Okay. There we go. I guess I might as well put the regulator on next, because it's on the top side. And then we'll get the resistors and capacitors flowing. There we go. Not bad. A little bit much solder in the joints there. Okay. I need to get a 1 mega ohm resistor out, and then we can do caps. Yay! This time I'll actually try and work them in an order that makes a little bit more sense as far as how to get to each of the joints. Let's go with this side first. Ah. That's not the time that you want to be just sliding all around the board. Oh, come on. There we go. Solder trying to pull onto the wrong side of my iron really doesn't help. So I've already got the pad tinned for the cap. Yeah, it was. Oh no! So they are very cute, but oh no! She's adorably cute, I know. I'm sorry for you that you can't really see what I'm doing here, but it's just more of the same. With even more flux binding problems. Ah. Every time I go to try and just push this one down, the flux is making it not. It's great. Yeah, hiccups can hurt, this is true. Just burning the flux off my tweezers because, I've had hiccups dislocate rib bones before. That sucks. So... Oh, come on, you... Well, it'll work. It just hurts a lot. While I'm here, I'm actually going to quickly neaten up the joints on the USB port because, well, I can, and it doesn't take much time. So let's put the resistor in for the LED. I might actually put the other resistor in, which is R12 down here, just so I've got all of those parts out of the way. That looks good. We just said this was R12 for the other two. Yep. Oh, it's soldered quite nice and easily. Yay. Okay. So we then need 0.1 microfarad caps. I've got a piece of sellotape in here that's supposed to be holding down this, and it's getting caps out from a real pain. Pun not actually intended. There's one. There's the other one. I pinged one, but like... I could. I was considering how I reattach... Well, you were seeing a piece of tape that's used to hold the leader down so that it doesn't just flap everywhere as you're moving the reel around. And it doesn't reattach to that plastic tape. And I don't have any sticky tape that's that thin. So, like... For the moment, I'm just leaving it on there because it's not that huge an amount of leader. If that makes sense. Hopefully that makes some sense. It might be, actually. I didn't have any until quite recently, though. Remember, I bought that during the keyboard stuff. Yeah, we did. And you make a good point, actually. I could use some Kapton to hold it in place. Which is probably going to be how I do it when I go and fix that up. I have a funny feeling this has got lyrics. Yeah, this has lyrics. I know it has. So I'll skip that one. Ah. There we go. That's close enough. It's on. It's not good, but it's on. Apparently we're doing C8 next, because that's the one that decided to bloody well take solder. Which is... which is 1 microfarad. Those are the LEDs which we're done with. Where did I put those caps? No, I need those two, but... There we go. Found them. I wasn't expecting to still be building power input circuitry at this point. I was expecting to be a bit further. Well... Aki's just the best. Yes, she is. I don't know what you mean about me being adorable. Wer sagt denn das? Okay. Also, bonus points to whoever both knows the song that I've just quoted the title for and knows what I just said. Agreed. It is an earworm. I'm assuming from that you know exactly who I'm referring to then. I said Verzaktendas. Whoopsie. I mean, that's not what the lyric means, but I figured from that you knew who the artist is, etc. I'm not saying on purpose, because I want you to go and find it and just... Yeah, it's a great song. Yeah. This is true. Sorry, Aki. No points for you. Well, No, you get bonus extra points for introducing me to the artist. There you go. That's how that works. Ow, love off. Huh, fair. Strange music video. Cool, but strange. I mean, that does just sum up, like, most of their music videos, to be fair. Okay, I think... I've got these two identical points. Yep, looks like. Excellent. Now I have no way of knowing which one's really which. This one's the one we've just been working on, so I'll put that out the way for a moment. Okay, the next thing to put on the board then, yeah, is one of these guys. Yeah, that's fair. I mean, you can kind of see it. In person. It's a black mark on black, but okay, there you go, you can just about see that. Yeah, I don't have any of them, so, like, best I can do is that right now. Let's get out. No, those are the... Just picking the wrong packet up. They're cute. That's adorable. Yeah, they did. I was impressed at that. That's slick. You like my silk screen, huh? It is a very nice silk screen. She is a very lovely dragon. This is an SPI flash chip. So because I've never used this chip before, well, it's A, really heartening to see pin 1 there and my pin 1 marker here line up. So we've got a good chance. What I want to do is I want to attach this because it's on the 3.3 volt side of things and just make sure that we don't get issues. Ah, no. Ah, come on. Yeah, explosions indeed. Those are the issues I am referring to. Let me check the alignment. Okay, these are adorable once mounted. they are a little bit of a pain to mount. Okay. Yeah, they are. I mean, let's let you see how... that's how low pitched they are. Yeah, they very small. It's like half a millimeter. Oh, the pin pitch is quite large actually. It's like 0.65, but they are not high off the board, which is actually the problem. They're not high off the board. I'm not quite happy with that reflow yet. Let's put some flux on this side. And a little dab on the back side. Good and fluxy. Oh, that's good. Sorry, you can't see a damn thing what I'm doing, but reflow seems to be successful. Oh, yeah, that's still hot. How do you know your reflow worked? Well, there ain't no flux on the top of the chip no more. So, let's just quickly do this side of the chip. Why, yeah, okay, but still. It'd be great if this would take some solder. Okay, that's actually made some really nice joints. And that side just took instantly. That's great. It's not bad. it's not great either, but it's not bad. I need a smaller tip. I was tempted to go and get like a 1mm tip, because this is a 1.8, which it does most stuff, but like, yeah, smaller tip might be a good idea. Now, I think... Is that 10k? Yeah, that's 10k. And it's almost like I can predict what what I use, rather. Now, this is a lot of leader. I need to cut this one. There we go. Just so much leader tape. That's right up to here. Is leader. I need to cut that. Yeah. Well, I've used a lot of these. To be fair, that's all usage. There we go. That's the giant mess removed. Ah, it's much easier to use this reel now. That's 2 resistors. Because I'll do... I'll actually keep that other resistor back for a moment. If it'll come off the tweezers. Alright, you're still really zoomed out. You can't see what the hell I'm doing. Apologies. That looks good. Oof. So, using another baggie, this one of oscillators this time, let us power this board up. We should see the power LEDs, well, one power LED come on only, and we should get no other things happen. I'm also going to have my machine monitor the output of D-message. Looks good. Flash isn't getting hot. I'm happy with that. No OC anything. LED comes up. Oh, it would wish. I mean, there's no processor, so... As we're doing these, I might as well finish. We might as well put the other one on. Just get that out of the way. And then... So there's another couple of resistors over here we need to do for these chips. And here. And then 2 caps. And then I guess it's the microcontroller next. Which is going to be entertainment. I am going... Pin 1's over here again. I'm going to tack down this pin over here. There we go. That took a bit too much trying to get it to take some solder, but it's taken some solder. Now, unlike the last time, I'm actually going to dollop a whole load of flux in that, because we're going to need it for the reflow. God, these are hilarious chips to work with, because they're so friggin' small. Oh, I should really say thin, more than small. Ah. Okay, that's some pretty decent alignment. Like a crisp. Yeah, I guess. Not nearly as tasty though. If that's your thing. I'm struggling to get this one to take some solder. And I've got to move the resistor. Which is kind of an obnoxious thing to have had happen. Oh hey, that took solder this time. Welcome, Bong Sniper. I didn't get the new small tip in. No, I made a value judgment call that I needed other things before I needed the new tip. Yeah. Sorry, you can't really see what I'm doing there. Looks decent. It is of course now nice and toasty hot. Ooh, that's not so fun. Oh, let's get some solder flowed onto the main pins of this one. Come on, take solder, yep. Okay, that took, finally. How badly did I munge that resistor? Pretty badly. Flop goes the resistor. Yeah. Well, that's a pain in the ass one to put in after the fact, isn't it? So, what this is telling me so far is that I need to adjust these footprints further to make them more hand solderable. Probably like another 0.2 or 0.3 millimeters on each of the pads out from the sides of the chips would really drastically help this. But, Mir! I like hand soldering, you know that. That's just mean. That's 3 of 4. Come on. The resistor's already taken. Fire apple bust. You want to see me cry, don't you? Oh god. No! Yeah, just throwing my flux pen. Point to point wire bonding. I guess. Sorry, I've had to grab the whole thing and bring it closer to my face so I can actually see what on earth is happening. Oh, this is just frustrating. I can't get solder onto that joint. I will have to clean this up before we can do anything more to that bit. And because of where it is, the resistor's gonna come flying straight back off if I try and put that on. So... isopropanol time! Yeah, that didn't take any solder at all. It just made a messy pad, which is great. Okay. I am not sure how I'm going to fix. I don't know if you can see that well, but there is no solder on that joint, and I can barely see the metal to attach solder to. Oh, would help if my iron was turned on. This is only because I messed up the hand solderable footprint. The footprint doesn't have quite extended out enough pads. So you're actually getting a demonstration for why I have my own package set. I mean, that's fair. I personally like the challenge of hand soldering, and I like the chill factor that you normally get. This is not obviously quite normal. The hand solderable footprint here isn't right. Fair. I can just about see a bit of metal right there, so... Hey, that got us a joint. Excellent. What I basically did was I basically pushed the solder wire into the joint as it melted, and that got us just enough, just long enough that it took. Ah, come on. There we go. Okay, the registration onto those pads is terrible, but it's on there. Was on there. Better. It's very hard to tell where that is spatially. Okay, that is actually on the pads this time. Yeah, you just get OCD, that's fine, but like, there is such a thing as good enough is good enough. And learning that point, which is what I've just had to do here, just takes practice. Especially one of the nice things with reflow with leaded solder like you're doing, your parts can be pretty skew width and they will pull straight. Because leaded solder has just such good surface tension. So, you know, drop the part on and more or less it'll be fine. To a point, that actually happens with hand soldering something like this too. So... it's not that bad. No, that's definitely not the part I was trying to click. So let's do the smattering of resistors here. I just showered the board in resistors. Whoopsie. That's 1, 2, 3, and 4. It's a happy little pile of resistors. As you can probably tell, I am far better with larger boards. This one is really quite testing me because it's so small and packed. Ah! Finger got stuck to the board. Thank you to Flux. Oh, I definitely need better work holding too. Esden did actually recommend me a work holding vice that I should get. Try it out, see what happens. Gonna be another one of those. Well, when I've saved up enough. And we're not doing keyboards. For, off the top of the list, for Bong Sniper's benefit, my main project is currently a massive keyboard. This is a slight distraction from that we've had running in parallel. Ah, that's fair. I had it this way around. I'm assuming that's a I'm gone wrong. It's just practice. I've had a lot of practice doing this kind of very fine work soldering. The ICs are easier. No. The resistors are easier. Especially if you don't have the right hand soldering footprints. Like, technically these are reflow footprints for the... Oh, yeah, no, you have to use hot air for that, but the pads for these resistors, etc. are basically reflow footprints. I'm able to solder reflow footprints for those, but the pads for main processor, I've had to adapt. Yeah, the advanced QFN stuff is machine assembly required, or rather, hot air or machine required. Like, you can't do those by hand, not this way. There's two capacitors. That's C20 and C19. Oh, come on. There we go. At least these are really easy to see on this map. This is... Oh, I know I keep saying that, but like, I'm so used to having to keep the parts pretty much on the board or they're gone forever. Oh, come on. Yeah, advanced QFN is where you have 2 layers of outer row pins. One entirely under the part, and one around the outside. I don't think that's lewd, but okay. Advanced QFN, I don't have any QFN boards handy. Ah, okay. You've got an outer row of pins around the part. Oh, okay, we're talking about work mats. I'm sorry, Come on. There we go. I catch your drift. That's not good. Nope. Guess you hadn't poked her camera in 20 minutes. Ah. Sorry. I think I know what Aki's just sent, but I'm gonna show it all the same. Oh, yeah, that's even worse. Oh, you can't see that? Oh, for fuck's sakes. I know why. Twitter... Where are you? Where are you? Yeah, this is just so cursed. I mean, just... Well, this is a form of advanced QFN. The one I was thinking of is you've got the pins around the outside as normal, like these normal pins, and then you have another row all the way around, and then you have a ground pad. Yeah. Oh, that's better. My back went. That was... satisfying. For me. Almost certainly that was Infineon. They love that kind of thing. Oh, yes, I gotta show stream that one. Yeah. Have hell in a package. Oh. Oh god. I mean, it would be BGA if there were balls on the bottom, but this doesn't come with balls on the bottom. It comes blank. I can already tell you that. Yeah. Ah. Ah. Yikes. Yeah, white quark is great. Yeah, Naz, you just get like like these regulators come without anything on the bottom, it's just the pads. This comes with just the pads. And you have to do everything else yourself. But the reason they've done it is because of the thermal pad. They obviously need some fairly specialized signal handling in the middle of the damn thing, and then you've got a pad, and you can't do that with BGA. You just can't get the solder to ball like that. I really wish this would stop breaking my display of the bill of materials. Right. After that hyper-cursed interlude, let us put the main microcontroller on here, which comes in a massively oversized bag. Just I mean, it's not even that chunky a microcontroller. That's a tiny microcontroller. No, it's not a tray. It's a box. For now, why? I have to appreciate the packaging. This is some absolutely stellar packaging, but like... Sure. There's my box with... That is because it is! Anti-stat. Clearly you've obviously had parts come in this kind of packaging before. It's just a foam tray. Yeah. The first time ever I don't feel bad about putting a microprocessor on my desk. And my pin 1 marker is right here, so that's all happy. Ah, that works. I thought it just... Yeah, that's because Farnell failed at packaging your part right. Usually they don't do that. Take care, Ness. Sorry that you have to leave us early. Well, yeah, you need to complain to Farnell about that because that usually doesn't happen, and that's usually because someone at the warehouse needs a good kicking. That's a mood. That aligned really nicely. Ooh. I mean, I guess. What I mean by good kicking is they just need telling, hey, you did this wrong. This is how it needs to work. Farnell are actually very good with the my stuff came shipped wrong. Because they supply so many fabs and major players in the business. So for them, it's a very major problem. Some good looking joints. And it's so stream can see. This is the main microprocessor. This is the Tiva-C that this is based around. There we go. Sorry, I'm trying to get the part right and it's just being a pain. Okay, that's better. Let's do this side next, which I've got some solder on there, so that's probably good enough. It's dry. Ah. Indeed. Fair enough. Okay. Last side. I'll add some more flux back on because this is apparently burning through flux quite quickly. Which makes some sense. Oh, perfect. So that's our main micro on. Just inspecting the joints. Ah, there are some shorts on this side. Close. Hey, there we go. Sorry, again, I'm having to keep this quite close to my face to see the joints well, because these are just tiny. This is why I hate working with this kind of package, but you can't get it in QFN. So that's one U1. R3 next. Another 10k. Fair enough. The smaller the merrier, huh? You don't want to do that. Thank you for reminding me. I have a board I need to show you. You don't want to do that. No, you don't wanna. I've tried it. No. Just no. Not with reflow, but the problem is to do with bridging under the bottom. They're so small you can't get mask in between the pins. Not really, at least. And it suffers horribly from bridging that you can't see to fix it. Yes, I did blow up a part. So, I'll quickly go grab the board. I didn't use reflow, but the problem is with bridging under the part. Can you see the part on there? It's right there, at the tip of my tweezers. What happens is you can't get the mask in under the part to prevent bridging. So this part suffers horribly from bridging problems. And it's this tiny little thing right here. Yes, I blew it up. Reflow will still struggle with this. I mean, That there is the part. It's fucking tiny. And I never want to deal with it ever again. Ever. That particular one has a short from 5 volts to the output. Right. I was about to go and do the crystal. Which is... I mean, getting the bill of materials plugin to run is still probably a really good idea. Because then it's one common piece of code working with both. I'm just going to double check that this is indeed a 25 megahertz oscillator, but it should be. Yep, it's a 25 megahertz oscillator. Not well documented that it is, because, whoops. But, I'll fix that. Ah, now that's a point. Which is pin 1? Oh, that silk screen needs improvement. Pin 1's over here. Looks like it's this pin here. Should mean it's that way around. This is getting jammed between parts. Oh yay. Okay. There we go. There's just a little bit of one of the corners that hadn't quite taken out. That's hot. Ooh, that could be problematic. Some of the solders made it up the side onto the upper can. I hope that's not a problem. We'll check the continuity before we plug this in. Right. Oof. Bad, Snapty. Bad. Where has the switches gone? There they are. Ah, these are cute. Thanks to Atty, I think it was, for suggesting these. Lyrics alert. Let's get the buttons. Well, switches. Ah. Ah. I nearly got it, and then I had to go and move it, didn't I? There we go. Can I get these to just slightly rotate? Yes. Yes, I can. Hey! SMD buttons. Some nice small ones. Fine, I'm gonna get the flux out in just a second to fix that little bit of a mess. Actually, I bet if I throw a little tiny bit of fresh solder in, it'll fix it. Yep. Less messy too. Okay, those have a nice feel to them. I like it. What else do we need to put on for this to be functional enough for a first boot? We need Ah, we need most of the rest of the caps. Starting with all of those 0.1 microfarad caps. Oh yay. I might as well just blast those on at this point. There's no harm. Yeah. Yeah. Oh, you sweepy? Okay. Well, sleep well, dear. You've done well today. Yeah, that's fair, Steffi. Let's see. Yeah. How many do I need? That's what I'm trying to work out. We've got... See... 21 here, so that's 1. 10. 13. 12 and 16, that's 5 so far. 9 and 15, that's 7. 4 and 5. And C11. So, 9? I think I count 9. That's 2. Four. Oh, come on. 6. Oh, it's 10. There we go. Nice pile of caps. Just strewn. Okay. There's just one that I haven't yet created the tacking for, which is here. Ah. It's very lucky that these... Hey, welcome back. Very lucky that these are literally a tweezer's width apart from each other. So I can just get my tweezers in there. How was the family bit, by the way, Naz? Other than, family. Think I haven't missed any. Ah, fair enough. Oh no, I missed C13. Ah. Those joints are looking a bit globular, but it's a full house. So that then leaves us... So we've done all the 0.1s. We've got two more 1 microfarads to go. So looks like it's C17 and 14, so right in here. Your family sounds awesome for what it's worth, Steffi. Oh, okay, fair. I mean, from the perspective of being able to relate to your dad, for example, through a hobby, I wish I had that. I've gone way more advanced with electronics and stuff to anything my dad ever did. So I might as well be talking German to him. I can't say French because he actually knows French. Okay, fair enough. Oop. Yep, that's starting to look like a sea of caps. We've done that one. Ah, good. We've got the 2.2 mics that go right in there. Naz, honestly, I'm just glad that you do. Yeah, I'm sorry to hear that, Steffi. That also seems to be fairly common in our kinds of story. Let's just say that things weren't always as good with my dad in particular than they are right now. And he has worked hard to rectify a mistake he made that severely damaged that relationship. Honestly, with my parents and the trans thing, they became okay with it the week that I wasn't able to take my full dose of HRT and I started slipping back into how I was at the end of my third year of uni. It wasn't pretty, but they got the point. They were like, okay, we get it now. And they really improved after that. They're really quite good with trans stuff. It wasn't their fault, by the way. But, like, that was their moment of reckoning. That was like, oh, this is what it means to be trans and to suffer. It's like, yep. That's a shame. I'm sorry. Yeah, that's a fair call. Fair call indeed. That's almost all the caps on. Right, I am going to quickly clean this board again. We'll do a little bit of multimeter testing to make sure I haven't generated a short on that crystal or on any of the power rails. Fair comment, Steffi. I think I wouldn't change mine anymore. There was a point where I seriously doubted them on a couple of fronts. But, like, no, they're pretty chill about it now, and they just treat me as their daughter. It's really cool. I really can't ask more of him. Oh yeah, no one's as simple as that. Anybody trying to say so is probably, well, racist for one. But a moron. That's the other major thing. Yeah. Oh, that was more IPA than I wanted. Oh well, my finger is now well alcoholed. Oh, guess who just took her board 1 mark off this board? Whoops! Yeah, that wasn't IPA resistant at all. Yeah. It'll be okay, Steffi. I know that this is board 1 at this point, like... yeah, that's very true. Right, I'm gonna dispose of the used piece of kitchen towel. Let's switch over to a quick test on the multimeter. Everything's caught up. Agreed, Naz, agreed. Aww. Steffi cutie. Mm-hmm. Ah, yes, fair. Trust me, living with your parents when you're out definitely brings them up to speed quite quickly. Okay, we've got no continuity there. That's actually a good thing. Believe it or not, I didn't want continuity there, so I'm happy. Shouldn't be any problems there. Right on. Good. Oh, that's categorically not a good sign. That's a dead short between power and ground. Yikes. I'm glad I didn't... I'm glad I didn't put power on this immediately, because, sparks would have flown. Oh, how to fix this? Yeah, that's fair. Okay. The iron back on. I'm getting the board file back out so I can see where power connections are that I definitely need to make sure haven't shorted to ground. Oh, I'm sorry to hear that. Yeah. Hugs, hugs. In this community, we got ya, fam. I'm actually going to do a little reflow on this guy, just in case, like, that's where the power short is. It's possible that it's on the micro. We'll also check that over. But this is like the obvious, it's not quite right, so... That's looking better. Where else could there be a power ground short? Oh, that would be right down this side of the microcontroller, right here. That would be really cool to be able to do. You gotta share the chapters with us. Wink wink, nudge nudge. Oh yeah, there's a whole lot of super spoopy stuff you can do. Who says you... Yeah, that's fair. Once you're living with your parents again, as painful as that might be, it would be really cool if you would actually scan at least some of those pages in. Oh, sorry. I'm having issues trying to get the multimeter, etc. in shot. Actually, I'm gonna zoom us all the way back out, because that makes life easier on everyone. Have we fixed the short? Who doesn't like short shorts? Muzzle tov! That's happy! We haven't got a short anymore! Oh, that's fair. Let's just check the impedance from power to ground. Several K. Yeah, that's fair. It's almost like there's chips in circuit or something. But at least we now don't have a dead short from power to ground, which honestly would have sucked. Oh, sorry, that was me dropping my multimeter. On the floor. Indeed. Right, let's interesting. That had power for a moment, and then it didn't have power. Oh, interesting, but it did enumerate. Fair enough, Steffi. Interesting. It's fine if I can't get the USB lines to connect, but as soon as I do... She ain't happy. Oh, interesting, but now she is happy. I'm gonna unplug her again. I'm just gonna do that from the PC side. Unplug her back in. Okay, that's fine now. I have a clean connect. Vice 9, and it's showing up as a Stellaris DFU. It's fine, actually. I think what might have happened was I might have had a little ball of solder or something else on the board, just making it just slightly unhappy, and putting my finger in there actually fixed it. Because it's happy now. So, we are now getting into the weeds a bit, we can now put on the logic level conversion hardware and that kind of stuff. Like we can put R2 on, we can put the diode on, and we will very shortly have a working board. It's enumerated, for crying out loud. Like, yahoo! See, well, hey, at least you got to see it enumerate. Which actually also means that the clock is working. So that 25 megahertz crystal, or oscillator, it's doing its thing. Good God, those are small. What have I... What? Oh my God, have I cursed myself again with tiny parts? Those are diodes! We spec them so that if someone tries to plug too high a voltage for the transistor into this, it won't cause any harm. Holy Christ, that thing's tiny. And stuck to my tweezers. Sleep well, Steffi. As I proceed to try and find the smallest small and solder it. Oh my God. What orientation is that even? Okay. The end that's in my tweezers and over the top of Toru is the end with the bar on it. Why is that valued as D Schottky small? Bollocks. I was supposed to put the part number in there. We'll try not to stay up too late. I'll try not to stay up too late. Okay, pin 1 is the one which has a bar over it. Which, according to this, is the bottom of the part pointing towards VCC. Should be about right, I think. Yep. Part pointing towards VCC. Okay. Just double checking. Yeah. This isn't gonna suck at all. Ha! Oh yeah, those hand soldering pads worked gorgeously on this one. Such a tiny part. Well, that's that one. Can you even see that? You just about. You probably got a better view of that than me, judging by that. Okay. I think it's time to put some transistors on. Let's start with Q3 here. If I can find them. Where's the translators? I'll put the diodes away before I lose them again. Those are so tiny. We'll need that in a bit. Switches, oscillator. We'll need that in a moment. There we go. Found them. Oops. Sending them flying. Go me. Okay. I am actually having a really bad time trying to figure out which pin is pin 1. I think I might have found pin 1. I think it needs to go that way around. We'll quickly check. To the schematic. Where is it? It's on the processor sheet. Some on-semi part. That's quite fun. There's a tiny dot in the top of the package. Oh, why? Yep. Yeah, I reckon that the orientation I've got it in at the moment is the right orientation. We just gotta tack them down. Ay, 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 ay. Oh, you just had to go twiddling on me. That's looking good on the alignment. I've still got it the right way around. The vote says yes. So... more solder went on the frickin' resistor pads next to it than actually on those pins. Dear goodness. Also, focus is not quite where we want it. That's probably about as good as you're getting, unfortunately. That's not bad. I'm using some functionality of screen and my capture card so I can actually see what you're seeing for once. Before even my computer sees it. Okay, that looks okay. Let's see if I can show you. This is very hard to really get you a good viewing of those joints, but it's not so much that, it's apparently my camera is deciding to give you a really shallow depth of field. Ah, there we go. Oh, that was a pain. Stuff over here is out of focus. Then it goes gradually more into focus and then back out again. I've got a really nice bokeh right where my hand is. Yeah, that is, I guess, kind of off the top, that's true, but like, I could definitely see the focus being impinged on those pins. Like, that's not really in good focus. Oh no, I'm sorry to hear that, Naz. Yeah, I wonder if my camera is running a... Well, it's running f-stop 10. That's usually okay. Just go just nuts on the f-stop, huh? That seems to have improved things a little bit. Cool. I didn't see that through all the flux. You can kind of just about see some nice shiny joints. Oh, it's got plenty of light coming down from up above. This is really well lit. Ah, you're kidding. I got solder in the frickin' hole. Okay. That works. So, let us do this resistor and that resistor next. Oh, and that one. Just 10Ks. 10Ks all around. Lots of 10Ks. There should be... Yeah, the one that's not a 10K is already populated. That's caps, not resistors. That would have been bad. Error. I flicked one somewhere. Ah, there it is. That's 2. Three. I accidentally put a hilariously large amount of flux on this part of the board. It's working. Don't get me wrong, this is quite the amount of flux to be working with. That, I mean, that's not bad as a net win. Better lose my headphones. There we go. Hey, nice! Congrats! I wish my headphones would stay on the top of my head. I need new headphones. Okay. Actually, before I put that last resistor on, I'm going to get out the transistors and get those on, because they're a royal pain in the ass to do otherwise. These are... I have a reel of them. These guys. My general purpose, I just need a MOSFET that's an NFET. Slowly getting through these. Takes a while. We actually need 3 of these per board. They're cute. Also, apparently I can now use my preview screen to help me fix my caps are, oh sorry, my transistors are upside down. There we go. Yeah, it's still upside down. Now attached to my finger. Oh, come on, there we go. They're cute. They're kind of huge, but they're also kind of cute. Right. Those are good pairs to start with. Seriously? Okay, that's one. Now it's upside down again. Okay. Let's reflow at least one more pin on each. Oh, fuck it, let's just do them. One more. There we go. Now I can inspect it. Not bad. I've done worse. Ah, my tweezers are horribly fluxy again. That's why I'm having problems. Cool. Bit far over, actually. Nice. Oh, it's so close to done. I can almost taste it. Got one more transistor to do, and then those ones are done. We've put the switches on. We've put those on. That's on. That's yet to be done. That's done. You're awesome, Naz. Oh, that LED's not yet in. We've done those. Did those. That's also a 10K, so we'll do that right now. Alongside both of these. So those are 10Ks. That's a 10K. We'll finish the backside off. Get those the right ones. Let's try and not solder her horns. The wagon no need soldery horns. Oh, come on. There we go. Okay. Oh, right, we were gonna do these two next. I can't even see where that went. Yeah, there it is. So what these two resistors I'm adding in right now do is they're pull-ups on the buttons. So this means that our user buttons will now function. Not bad, not bad. Okay, we are on the final leg of it. Let's get a transistor on so that we don't have to deal with any more transistors that are just single package. Yeah, functioning buttons is definitely, well, helpful when you want to try and squirt what's in these two out onto your target. This is really coming together nicely. I'm very happy with this. Right. We've done that. Resistor-wise... That's a 10k. That's a 10k. That's a 10k. That's a 10k. I'm gonna put the LED in before I try and do any more resistors, because we'll just get those resistors done in one shot, but that LED is gonna be a bit more trouble. Come on. It's in here somewhere. There has to be, right? Supposed to be two in here. Oh. Sandwiched between the packaging to keep them dry. Wonderful. I feel my tweezers are really sticky again. Oh, that's lucky. Bumped the packaging and it came out the right way up. I put that straight back in its packaging because I really don't want to lose any of these. I intentionally didn't buy very many of them. There's a bar on the bottom of the package that's seemingly pointing towards pin 1. Ah. Which says it should be that way around. Let's check. So I'm going to quickly clean up in my Gerber folder for this project because I still have that particular bit open and I clicked on it by accident. That data sheet. Anode mark. Apparently I need to look for the anode mark. Oh, I was about to go and put it on backwards. I'm glad we checked. It's actually that way round. Ah! Yes, just make your really tiny little part really hard to read so that people put it on backwards. Oh, now that's an interesting point. I think it's actually supposed to be that way around. Whoopsies. We nearly did that wrong. That would have sucked. That looks decent. I guess. Yeah, that's actually the right way around now. Cool. Oh, the really funny part is that it says, oh yeah, it's Broadcom. It's not Broadcom. It's actually a Vago, but they got bought by Broadchip. Isn't it really more like Broadcon? Yeah, Broadcon. Let's go with that. Cool. That's our RGB status LED. Looks reasonable. I don't see any shorts, so that's a very good start. And now I can put the 4 resistors on, leaving us just with a QFN part to do, which is the logic level translator. Apparently that pad's already got solder on it, so we'll turn it this way around. Do that way. It is a it's a general purpose microcontroller by Texas Instruments called a Tiva-C, which is basically an ARM Cortex processor. M series Cortex. Pretty nice part actually. And because of the Tivaware, as it's called, it already enumerates as a device firmware upgrade target. Oh yeah. But we're not actually going to be using their DFU, I think, because I've got a JTAG header here. And it makes more sense for me to use the JTAG header and a Blackmagic probe, and then I can debug as well as program this thing. But like, it already enumerating really helps us know that we got our USB design right. And like, the crystal here is working, and exactly. We're just going to use that as our dev mode, that we're going to be using an in-circuit programmer, well, technically a JTAG adapter, Blackmagic probe, to program and develop on this board, because it's easier. And then once, you know, it's all said and done, end users will just be able to DFU the firmware blob on, and voila, that's the board bring up. That's a horrible angle. Cool. I think we power this on again real quick, just to make sure we haven't broken anything. Just as soon as I've programmed, soldered on the logic level translator, which is right at my bottom of my parts set, I think. No, that's a rectifier. It's there. Oh, these are cute. At least they're easy to read. So pin 1's over here. Which means that way around should be right. Huh. That really doesn't want to focus on that silkscreen, or that silkscreen is just garbage. Pick one. Looks about as good as I'm going to get that again. I should actually put these away again so that I don't lose them. That looks good. It's almost like we've got a whole lot of experience with me doing these parts. Now my alignment is off though. Oh, and there's a problem with this. It shouldn't be a big deal right now, but what's missing on this backside? Ah! Yeah. I forgot to expose, like I did this ground pad. Fuck. Oh well. Huh? Okay. Did that improve the registration of the part any? Kind of. That was my neck. Wonderful. There we go, that got it. Just a little nudge. Yeah, it just means that we won't have good heat sinking on this part. Like, there is a ground, so it will have ground. Not all parts are like that. But it probably won't really like me very much that it won't have its bottom side pad soldered. Not really, at least. It'll be fine, but it just won't like me very much. Soldered fine though. It's almost like we've tuned that particular hand solderable footprint really, really well. The only thing I have left to solder on is the header that connects the Blackmagic probe. I think I want to clean the board and check it's still powering fine. Oh, and also the target connect, that's the other one. I'm gonna check that this board still powers happily. I'm gonna make sure we've got no shorts anywhere we don't want them. Then we'll do the last two connectors. That'll be where we wrap the stream up. And I'll put the other parts away and all that fun. I now have pieces of metal embedded in my ESD map. Fair enough, Atty. It's been great having you here. Take care. Welcome, Stolarix. I'm really happy with how this has come along. I need to go and grab a piece of kitchen roll. And then we can isopropyl boards. Not board, I should say. Awesome. Well, welcome to the family, as it were. What I'm currently doing is I'm currently cleaning up all the flux that's accumulated during my rework of this board as I've put the parts on. Excellent! Well, after I've got this board up and working fully, this is the first ever bring up of one of this board, I will be writing new firmware for it, so do stick around. You might find it's just your thing. Well, hopefully you won't get to deal with quite such tiny parts as that little bugger right there. It's a diode, not that you'd know from seeing it. That's looking pretty good. Good, good. A decent soldering station, or a decent soldering iron at least, is definitely very helpful for learning and just generally a good idea. So you're already off to an excellent start in my books. I've been doing this a while, if you couldn't tell. I will try and not be up until daybreak. Take care, Naz. It's been great having you around. So, just gonna insulate it off my ESD mat here because it turns out this is conductive enough, it causes problems. And let's see. We get power. And no popping or anything like that. It's all nice and chill. That's good. So, with that, wrong ring. I am now going to add the programming header and the target header on. And we get to test the fit between these and the Blackmagic probe, which I've had sitting off camera most of the stream. Which is a shame because it's a really lovely board. Come on. There we go. Out of interest, Stolarix, was your board primarily through-hole or surface mount parts? Just intrigued. Nothing more. Noting that this board obviously is mostly surface mount parts. Oh, okay. Ooh, interesting. I assume you've read the safety brief, as it were, on how to not kill yourself with a Tesla coil. Because those things do produce very high voltage, after all. Ah. Basically, don't touch the end that makes sparks. At least not directly. It is very low current, but it's at a voltage high enough. It's pretty high. Just saying. Let's just say that skin effect no longer plays much of a role if you directly touch it. Ah, awesome. They're personally not the tools I would use for that, but I'm not going to dissuade you because they are excellent starting points. Although Arduino is itself kind of problematic as a start because they have what they call Arduino C, which is not, it's C++. I think they named it that way so that it would scare people off less. And the IDE is not very good as overall embedded programming tools go, but like I say, as a start, it's fine. It's not bad. Let's just check that I've not caused any shorts. Nope, we're good there. Excellent. That's fair. Okay, let's get rid of the... this little wonderful thing is designed so that a pick-and-place machine can pick this part up and place it. Otherwise, you know, all the holes would cause problems with the vacuum system. So that's what this little clip's for. But we don't need that, because I'm no stinking pick-and-place machine. I am a human. Weirdly enough. Let's check. Does this fit? It does. Ooh, that clicks home very nicely. So that board on the top in purple is a Blackmagic probe. Is a JTAG adapter that can talk with this processor, which is a Tiva-C. You can actually see the part number quite nicely there if I turn that to the camera. Yep. So that's awesome. We better check that we have got the pinouts right, etc. I mean, in theory I have, because I have got the schematic for... Well, sorry, not the schematic. I've got the board for this, thanks to Esden. But I worry. So we will quickly check the pinouts with my multimeter. Awesome. Thank you for the follow. Oh. Let's see. Testing points are fantastic in this case. I can check. I've got ground continuity. Yep. But not power. But not power there. And not power here. Yes, good. VCC of the black magic should be hooked up to that. It is. Ah. Awesome. There aren't really any other testing points I can actually get to, but we can do a quick check that no shorts with it plugged in. That's good, actually. I think that's enough of a test to make sure that we're not going to get problems when we use the black magic on this board. Awesome. That leaves us with the target header. Just quickly putting my multimeter probes away again. When I can get them to unkink. And so our last contestant for the night to get put on a board is... not that one. Where's the frickin' headers gone? There they are. Headers! These are really cool, actually. I do need to complain to Farnell that one of them came bent. Can't remember which one now because I bent the pin back. But I do need to complain to Farnell about that. That looks just so nice. I've got a work holding problem. I do that. I think that will be good. Yeah. Well, that's gone in really awesomely, so... That has gone together so nicely. Save for one joint which needs a little bit more reflow because it didn't quite flow through to the top fully. Which is this end one right here. That should probably do the trick. Close enough. Yep. Yep. Don't drop it. Those have all come out nice. A little bit pokey bit out the top, or the bottom rather, but that looks good. Looks good to me. Toru says, yeah. Actually, no, she probably wouldn't. She's more like, Gao. This dragon. Toru approves. So with that, one more power up, and we'll finish up. Just want to make sure that it's a happy board that powers properly. Curious, that shouldn't be able to blink on and off. It enumerates. Seems okay. Oh, interesting. The lines going to that LED are so high impedance, I can turn them on with my bare finger. Oops. Oh well, that's fine. At least it's not blinding. That was the reason I've got it dimmed down like I have. So I can do that. Which is not great, but that's okay. It's not too bright, at least. And then the other thing we want to do here is plugging the black magic probe into it doesn't do anything to the power indicator. That's a good sign, honestly. And I have another USB cable here. Ooh, nearly smacking the live board with the USB cable. Yeah, that would be such a fitting end to the stream. And if I put power... go in the friggin' USB socket. There we go. If we put power to my Blackmagic probe... then I see a power LED on that board. That's happy. Try and get it to stay still. So we've done that now, we've done that now, those are all done, that's done and that's done. Yay! Yeah, that'll do. Do I have it built enough to where... No. At least it doesn't take long to build. There is... Why did I only do J4? No, whatever. Oh, interesting. This is going to be that I don't have a UDEV rule for that board set up yet. If we look at LSUSB, curious. Should be able to find it. It doesn't find it. This is Blackmagic Pro firmware for what it's worth, so it should just work. But anyway, I'll figure that out off stream. For right now, I'm just happy that we have... I don't think Blackmagic Pro actually booted. That's curious. I've got to check that that USB cable is actually a full USB with data and not just power. Anyway, I am really happy that we now have a fully working SPIFlashProgrammer revision 2. And this thing really looks the business. I'm thrilled. Thank you all for watching. It has been an very interesting adventure. I have another one to build. I might do an impromptu stream tomorrow to do that. I will be streaming MX Keyboard, in all likeliness, next Saturday. So that should be an interesting... Trying to finish up the last of the respin. There's still a couple of things I need to do. And with that, have a good rest of your day, and I will see you there and then. Take care, everyone. Bye.